This lesson is how to prove a quadrilateral is a kite or trapezoid in Unit 12. I'm starting on page 10, and we'll start with proving a quadrilateral is a kite. Step 1, you need to find the distance of all four sides, and you must have two pairs of consecutive congruent sides. So the first thing we want to do is we want to graph our kite. So our G is at -4, +4. O is at 1, +4. A is at 6, -6. And then T would be at -4, -1. So this is G, O, A, T. We can use our straight edge and make our lines. And we have our kite. So the first thing we need to do is we need to make a table to find slope and distance of each of these lines. So GO, it's on a horizontal line, so we can just count that to find the distance. It's 1, 2, 3, 4, 5. It's a horizontal line, so we know that our slope is going to be 0. OA, we can't figure out the distance by counting since it's at an angle, but when we figure out our slope, we can use the Pythagorean theorem to figure out the distance. So if we make a right triangle, that helps us also to find our slope. Our rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a negative slope, and our run is going to be 1, 2, 3, 4, 5. So we know that that's going to be a negative, 10 divided by 5, that's going to be -2. But it's important that we keep it in this form because we can figure out our distance by saying the square root of 10 squared plus 5 squared. And that will give us the length of our hypotenuse, which is OA. So we can just plug that into our calculator. Control X squared, 10 squared plus 5 squared equals, we get 11.2. Our next line segment is AT. Again, if we figure out our rise over run, this is going to be a positive. No, this is also going to be negative. It's also going downhill. That's what we figure from left to right, it's going to be negative. So our rise is 1, 2, 3, 4, 5, and our run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this time it is -5/10, which is -1/2. Our distance is going to be the same though, because you're going to have 5 squared plus 10 squared. So that's going to be the same. Those are congruent. GT is a vertical line, so we can count it. 1, 2, 3, 4, 5. That's our distance. Our slope, since it's a vertical line, we know that our slope is going to be undefined. So we found the distance and the length of all four sides. We've also found the slope. We need to prove that we have two pairs of consecutive congruent sides. So number 1, that was step 1. We know that GO is congruent to GT, and also OA is congruent to AT. So we figured that out with the distance formula. Step 2 says to find the slopes of the diagonals and see if they're perpendicular. If I drew the slopes here, the diagonals, and figured out the slopes. I know that this distance is 10, this is 5, and this is 1, 2, 3, 4, 5. So the slope of GA my diagonal GA is going to be negative 1. And we can also see that it goes down 1 over 1, down 1 over 1. So let's find the slope of our other diagonal, which is OT. And that is going to be, this is 5, and we know that this is also 5. 5 over 5 equals a positive 1. These, because this is negative 1 and this is 1, they are either, you can say that the product of the two slopes is negative 1, or they are negative reciprocals, and so therefore we know that they're perpendicular. GA is perpendicular to OT, and those are my diagonals. So we have proved in 2 steps that this is a kite. Go to the next page, page 11. We're going to prove that this first example is a trapezoid. So first thing we're going to do is we are going to graph it. K is at 1, 5. A is at 4, 7. T is at 7, 3, and E is at 1, negative 1. We connect our points. And we have a trapezoid. So our first step is to find the slope and distance of each of these line segments. So I have KA, AT, TE, and then EK. Slope of KA, it's going uphill, so it's going to be a positive slope, and that would be 2 over 1, 2, 3. 2 over 3. My distance, I can use the Pythagorean theorem because 2 and 3 are my legs. So it's going to be the square root of 2 squared plus 3 squared. And I will get control x squared, 2 squared plus 3 squared, 3.6. Okay, for AT, it's going to be a negative slope because it's going downhill. So my rise is 1, 2, 3, 4 over my run, which is 1, 2, 3. So if I did the Pythagorean theorem, it'd be 4 squared plus 3 squared, control x squared, 4 squared plus 3 squared, I get 5. TE, 1, 2, 3, 4, it's positive over 1, 2, 3, 4, 5, 6. That will reduce to 2 over 3, but it's always good to have it in this original form because that's how you find out the distance. And so 4 squared plus 6 squared, control x squared, 4 squared plus 6 squared equals 7.2. Line segment EK, that is a vertical line, so it's going to have an undefined slope. And we can count the distance, 1, 2, 3, 4, 5, 6. So there we have our slopes and distances. The only thing we are really concerned about proving in a trapezoid, we know that it's not going to be isosceles trapezoid because we don't have two sides that are equal. are congruent. So if we can prove that we have a pair of, this is for parallel lines, that they are parallel. So what we're proving, this is isosceles. We want to prove that one pair of sides are parallel and one pair of sides are not parallel. So if we look at these two have the same slope. So we know that KA is going to be parallel, that's the symbol for parallel, to TE. But we also know that AT is not parallel to EK. So we proved that it's a trapezoid, but it's not an isosceles trapezoid. You couldn't see everything I was writing. There we go. Number 2, prove that the quadrilateral MILK with vertices M, that's 1, positive 3, I is at negative 1, positive 1, L will be negative 1, negative 2, and K is at 4, positive 3. Connect my lines. Now we're going to set up our table to find slope and distance. MK, KL, LI, and IM. MK, our slope, it's a horizontal line, so our slope is going to be 0. So we can count our distance, 1, 2, 3. KL, it's going to be a negative, no, it's positive, it goes uphill. See, sometimes I have to stop and think about it too. And so the run is going to be, the rise is 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, which equals 1. Our distance will be the square root of 5 squared plus 5 squared. Control x squared, 5 squared plus 5 squared equals 7.1. Li is vertical, so the slope is undefined, and the distance is 1, 2, 3. IM, 1, 2, rise is 2, the run is 2, and it's going uphill. So the slope is 1, and if I did the square root of 2 squared plus 2 squared, my original numbers, the legs of my triangle, control x squared, 2 squared plus 2 squared, I get 2.8. So, do I have two pairs of sides, a pair of sides that are parallel and a pair of sides that are not parallel? These both have the same slope. So I can say that KL is parallel to IM, and the other two are 0 and undefined. So they are not going to be parallel. MK is not parallel to LI. Now we need to look at the distances. I have two sides that are the same, so that means it's going to be an isosceles trapezoid. So since MK is congruent to LI, we can say that it is an isosceles trapezoid. There are some other problems that y'all can work on your own. We've showed you how to do 3 of the different types, so you can work on those for part of your assignment. Good luck.
Stop. I know. That was a long time.
How long was it? So, and I may not want to save it because I think I was working and you couldn't see everything I was doing. So, I may just want to look at it tomorrow. Can't play. What? I never know how to get out of this. Oh, that's not what I wanted to do.
Back arrow.
Oh, well no, I don't want, I want to get out of this, period, this whole thing.
That works.
Ladybug, no. Hello, my ladybug. I have to start all over again.
And I don't think it's gonna change.
Size, 0 bytes.